Okay, so we are working on, this is the second video for 5.4. We're talking about number 17. This was a very requested video, and we already worked through in the previous part 1 of this video, A through D, I think. Yep, and now we're working on part E, and it says approximately when is the acceleration 0? So as a reminder, we have this graph, and it is the graph of a position of the integral of f of x. Therefore, that means this graph is a position, not a position function. It is a velocity graph, but it's represented by this equation up here. So with this velocity graph, we're wondering when is the acceleration 0? Well, the acceleration is 0 when it is a max or min of a velocity. Since the velocity is this graph here, this is a graph of the velocity, we're going to go look for maximum, and our maximum is at approximately 7. So the acceleration is 0 at f prime of t is equal to 0, which is either maximum or minimum, and that is at x is equal to 7. Okay, when is the particle moving towards the origin? When is it moving away from the origin? When we're talking about direction and whether it's moving away or towards, we're talking about velocity. So it's moving away from the origin at a positive velocity. And then it's moving, we have to figure out where does the particle start, and then we can decide whether it is a positive velocity or a negative velocity that's moving towards the origin. So when we start here, if you look at the area between 0 and 3, it's a negative area. So that means that during the time 0 seconds and 3 seconds, this particle moved to the left. So between 0 and 3, this particle moved left away from origin. And then between 3 and 6, it moved towards the origin. And I'll tell you why in a second. Okay. We went a certain amount of area to the left. We started somewhere. We started probably to the left of the origin because we went even more left, and then we moved right so that we could go back. By 6 seconds, we had moved left and right back to the origin. And then after 6 seconds, because our velocity is still positive, we're moving more to the right. So between 6 and onwards, in this case, let's say about 10, or let's say when x is greater than 6, the particle is moving more to the right of origin. Okay, so which side of the origin does the particle lie at time t equals 9? Let's see. Let's go back to our graph. In the previous video, we talked about how the particle reached the origin at t is equal to 6. It had gone to the left for 3 seconds, it had gone to the right for 3 seconds, and it made it back to the origin. Now, after the origin, between 6 and 9 seconds, this positive velocity tells us the particle is still moving to the right. So that means that the particle is to the right of origin at t is equal to 9. And that's how you can justify that answer. Okay, you should annotate. If you have any other questions or comments, please bring them to class tomorrow. Bye.